Hello everyone, in this lecture we will study about small signal operations of a simple op-amp and slewing during transitions. Okay, so to understand the origin of slewing, let us replace the op-amp of what we have studied in the last lecture by a simple CMOS implementation, and assuming for simplicity that this R1 plus R2 is very large. We first examine that the circuit with a small input step. Now, if this V in experiences a change of del V, then this ID1, current ID1 increases by Gm del V by 2 and this ID2 decreases by Gm del V by 2. And since the mirror action of M3 and M4 raises ID4 by Gm del V by 2, the total current is Gm del V. Okay, this current begins to charge this capacitor CL, but as this Vout is higher, so does this Vx increases. Okay, and it will reduce the difference between Vg1 and Vg2, and hence the output current of the op amp. Okay, now suppose del V is so large, this del V is so large that M1 absorbs all of this ISS, which will turn off the M2. The circuit then reduces as shown in this figure. Okay, M2 is off, the circuit reduces to this particular configuration. And so long the M2 remains off, the feedback loop is broken. Okay, and the current charging this particular CL is constant and it is independent of this input level. And if the input drops such that M1 turns off, then circuit is simplified as shown in this figure. Okay, and now what we get this V out like this. Okay, both are different. Here we are transiting this from low to high, and in low to high transition this M2 remains off. Okay, and this charging of capacitor is done by a constant current, and when this input voltage is high to low, this M1 remains off and the V out becomes like this. Okay, so this particular slewing is an undesirable effect in high-speed circuit that process large signal. And when the small signal bandwidth of a circuit may suggest fast time domain response, the large signal speed may be limited by the slew rate, simply because the current available to charge and discharge the dominant capacitor in the circuit is small. Okay, and moreover, since the input-output relationship during slewing is non-linear, the output of a slewing amplifier exhibits substantial distortion. For example, if a circuit is to amplify a sinusoid, that is V naught sine omega naught t, in the steady state, then its slew rate must exceed V naught omega naught. Okay, so this is about the slew when we transit input low to high or how to low, how our output changes. Thank you.